Welcome to my channel. This is Gushito, and what I do here is solve technical problems and also provide very important information that can help you to have a better performance in your technical drawing examinations. If you are watching my video for the first time, thank you, and I want to ask you to subscribe to this YouTube channel and help me to share my videos to your friends who are technical drawing students. As I said, I share important information on this YouTube channel, which is meant for technical drawing, and you are going to learn a lot when you go through all the videos that I've made and the ones that I'm going to make as we move on. Okay, so now I want to talk about solids. I want to talk about solids, and we are going to look at a lot of things that we need to know, that we need to bear in mind when it comes to solids in technical drawing, even in mathematics. So let's go, as we are going to be talking about this topic on solids. Now, so the next slide, we have types of solids. Types of solids. Some students don't know this, but you are going to learn here right now. Okay, so solids solids are divided into two, or we have two types of solids. We have the ones that we call polyhedra, and we have solids of revolution, polyhedra and solids of revolution. Now, for polyhedra, so examples of polyhedra are also divided into 7. We have tetrahedron, we have cube or hexahedron, we have octahedron, we have dodecahedron, we have icosahedron, we have prism, and we have pyramid. So I believe you are familiar with most of these solids, or some of them, I mean polyhedra solids. Then we also have solids of revolution. Among them, we have cylinder, we have cone, we have sphere, we have frustum, and we have truncated solids. Now, what we want to do right now, after we have talked about the types of solids, I want us to focus on one of these two, and we are focusing on polyhedra. So we talk about the properties of tetrahedron, properties of cube or hexahedron. We talk about properties of octahedron, dodecahedron, icosahedron, prism, and pyramid. So all these properties that we are going to talk about each of these polyhedra are very, very important. So please go along with me and make sure you pay attention to what I want to discuss with you here now on this particular topic in technical drawing. So now let's look at the properties of polyhedra and their properties. Now we are starting with properties of tetrahedron. So this is a tetrahedron. This shape is a tetrahedron, and we have the properties of tetrahedron here. So the first property that we are talking about is that a tetrahedron has 4 equilateral triangular faces. It has 4 equilateral triangular faces. This is one face. This is another one. There is another one at this part, and then we have one down here. So all these faces are equilateral triangular faces, and then it has 6 edges. It has 6 edges. What are the edges? So an edge is a line where 2 faces meet. So I mean this face here, this face and this face, they meet along this line. So this is an edge. And for this tetrahedron, it has 6 edges, as I said. Let's look at the number of edges that we have here. So we have, this is 1, this is 2, this is 3, and this is, we have 1 here. So this is 4, 5, and 6. So it has 6 edges. Then it has 4 vertices. 4 vertices. So this is 1, 2, 3, and 4. Those are the vertices on this tetrahedron. So the properties of tetrahedron are as outlined here. Now, so we are done with tetrahedron. Let's look at cube or properties of a cube. So for a cube, number 1, it has 6 square faces. It has 6 square faces. So we have what? We have 1, we have 2, 3, 4, 5, and 6. So it has 6 square faces. Okay. Then we also have that it has 12 edges. It has 12 edges. Where are the edges? This is 1, this is 2, this is 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So those are the 12 edges that a cube has. Then we also have that it has 8 vertices. 8 vertices. So where are the 8 vertices? We have 1, 2, 3, 4, 5, 6, 7, and 8. So those are the 8 vertices on this cube. Then we also have that opposite faces are parallel. Opposite faces are parallel. So this face here is parallel to this face. This face is parallel to this face, and this face is parallel to this face. So those are the properties of a cube as a polyhedral solid. Then the next one, we have octahedron. So the properties of octahedron, so number 1 is that it has 8 equilateral triangular faces. It has 8 equilateral triangular faces. So this is 1, 2, 3, and 4. Then we have 1, 2, 3, and 4, making 8. So that is the first property. Then it has 12 edges. It has 12 edges. So where are the edges? It has 4 along this part, 4 along this part, and 4 along this part, making 12. Then it has 6 vertices. So where are the vertices? 1, 2, 3, and 4, 5, and 6. So those are the properties of a octahedron. So let's move on and look at the next one and its properties. That is, we are talking about dodecahedron. So for dodecahedron, it has 12 regular pentagonal faces. 12 regular pentagonal faces. Okay. Then it has 30 edges or 30 edges. So there's an error here. So it has 30 edges. Okay. So then it has 20 vertices. It has 20 vertices. So those are the properties of a dodecahedron. Then we move on to the next one, that is icosahedron. So for icosahedron, it has 20 regular pentagonal faces. 20 regular pentagonal faces. Then it has 30 edges and it has 12 vertices. Okay, so those are the properties of a icosahedron. Then we move on to another set of polyhedral solids that we call prisms. Okay, so let's look at the properties of the prisms. So, and before I move on to talk about the properties of prisms, so prisms, they are named based on the shape of their cross-sectional area. What I mean by cross-sectional area, this is a cross-sectional area, and this is also a cross-sectional area. So we use the shape of the cross-sectional area to name them, not the shape of this face. These ones are the faces, okay? But the shape of the cross-sectional area are used to name them. As we talk about this one, this particular prism is a triangular prism. Why? Because the shape of the cross-sectional end is in form of a triangle. So we call it triangular prism. And as we have here among the properties, that it has 3 rectangular and 2 triangular faces. So 3 rectangular faces and 2 triangular faces. So triangular faces are the cross section. So while the rectangular faces, we have one here, and there's another one here. So it has 3 rectangular faces and 2 triangular faces, which are for the cross section through which we name them. Okay. Then it has 9 edges. It has 9 edges. We have 3 up here, we have 3 around here, and we have 3 edges down here. So making 9 edges, and it has 6 vertices. So where are the vertices? We have 1, 2, 3, 4, 5, 6. So those are the 6 vertices that a triangular prism has. Then let's look at the next one among the prisms. So we have a square prism. So as I said, that we usually use the shape of the cross-sectional end to name them. So this is a square prism. And for this square prism, the property says that we have it has 4 rectangular faces and 2 square faces. 4 rectangular faces and 2 square faces. These are the 2 square faces. This face and this face are the square faces. Then 4 rectangular faces. Then it has 12 edges. 12 edges. So 12 edges, we have 4 up here, 4 around here, and 4 down here. So making it 12 edges. Then it has 8 vertices. It has 8 vertices, 4 up here and 4 down here. So those are the properties of a square prism. Then the next one is a pentagonal prism. So the shape of the cross-sectional end is a pentagon. So that's why we call it pentagonal prism. So for the properties, it has 5 rectangular faces. Because the shape of the cross-sectional end is a pentagon, so it has 5 rectangular faces. Then it has 2 pentagonal faces, which are the cross-sectional end, the shape of the cross-sectional end. Okay. Then we also have that it has 15 edges. It has 15 edges. So 5 up here, 5 around here, and 5 down here. So making it 15 edges. Then it has 10 vertices. So 10 vertices. The vertices are, we have 5 up here and we have 5 down here. So those are the vertices, and these are the properties of a pentagonal prism. So as I said, we have what? We have 15 edges and 10 vertices and 5 rectangular faces and 2 pentagonal faces. Those are the properties of a pentagonal prism. Then let's look at the next one. That is hexagonal prism. So for an hexagonal prism, so as I said, we use the shape of the cross-section to name them. So the shape of the cross-section of this prism is an hexagon, a 6-sided polygon. Okay, so as we have among the properties here, we have that it has 6 rectangular faces and 2 hexagonal faces. So because it has its cross-sectional end is in form of a hexagon, so that makes it to have 6 rectangular faces. So then we have 2 hexagonal faces. Those are the cross-section. Then it has 18 edges. 18 edges. So 6 up here, 6 edges around here, and 6 edges down here. So making it 18 edges. Then it has 12 vertices. It has 12 vertices, 6 vertices up here, and 6 vertices down here, making it 12. So these are the properties of a hexagonal prism. So the next we have what? We have pyramids. Okay, so we have all the properties here all together. So for the first one that we have here, so we have what? We have so we have triangular pyramid, and as we did for that of the prism, so we also used the here we use the shape of the base. The shape of the base is what we use to name the pyramid. So for this one now, this is a triangular pyramid because the shape of the base is a triangle. So for triangular pyramid, it has a triangular base. That's triangular base and 3 isosceles triangular faces. It has 3 isosceles triangular faces. So as I said, it has a triangular base and 3 isosceles triangular faces. So that is one of the properties of the triangular pyramid. Then it has 6 edges and 4 vertices. 6 edges, 4 vertices, as we have here. So 6 edges, we have 1, 2, 3. Then we have 3 down here, making it 6. And the vertices, we have 1, 2, 3, 4. So those are the properties of a triangular pyramid. Then we also have square pyramid. The shape of the base is in a square form. So as we have here, it has a square base and 4 isosceles triangular faces. Then it has 8 edges and 5 vertices. So 8 edges, we have 4 around here, and then we have 4 down here, making it 8. Then for the vertices, we have 1, 2, 3, 4, and 5. So those are the properties of a square pyramid. Then we come to pentagonal pyramid. as we have here, the shape of the base is a pentagon. So we have the property here that it has a pentagonal base and 5 isosceles triangular faces. 5 isosceles triangular faces. It has 10 edges. 10 edges, 5 here and 5 down here, making it 10. And it has what? It has 6 vertices. So 5 vertices down here and 1 there, making it 6. Then we come to hexagonal pyramid. So the shape of the base is an hexagon. So that's why we call it hexagonal pyramid. Then it has a hexagonal base and 6 isosceles triangular faces. Then it has 12 edges. So 6 here and 6 down here, making it 12 and 7 vertices. So 6 vertices down here and 1 there, making it 7. So those are the properties of hexagonal pyramid. So all this worth sitting down to learn. So when you study all this, be able to give the right answer when it comes to the objective question in technical drawing. So I believe with this explanation that I made, everything about solids is clear to you. So the next video on the solids will be for that of solids of revolution. Thank you and keep on practicing. God bless you.